Question 5. Complete the theorem that states the line from the center of the circle to the midpoint of a chord
is equal to 2 times the angle of the circumference.
The line from the center of the
circle. Wait, the line from the center of the circle to the midpoint of the chord. It's what is it? Does it not bisect the chord?
Yes, it bisects the chord because it's this one, right? The line from the center, it's the radius, and then to the center of a chord, it's what?
It's bisecting.
Since in this case they already said to the midpoint of the chord, so meaning we already told that it bisected. So we now need to say what? It's perpendicular to the chord. Because remember, if it's going to the midpoint, then it's what? 90 degrees.
Wait, so what?
It's perpendicular.
Wait, complete the line from the center of the circle to the midpoint of the chord is perpendicular to the chord.
Yes.
So now we can't say it bisects the chord because they already
told when they say that it's going to the midpoint. So once they say midpoint, it means that it bisected. So if they had asked saying the line from the center of the circle perpendicular to the chord, then that's when you'd say, so if it's perpendicular to the chord, then it bisected the chord. Okay. Write down the converse of theorem 7.1. This theorem.
So now are they talking about
what I just said? That the line from the center of the circle perpendicular to the chord bisects the chord. That's the converse.
Wait, is it just the one with...
It's just this one. They're just playing around with words.
Why didn't they say the converse?
Yeah, the converse is just inversing. Actually, in this case, they told me that the line is coming from the center and it's going to the midpoint, meaning they told me that it bisects the chord, right? So now I have to tell them that, okay, so since it bisects the chord, that means that it's what? It's perpendicular to the chord. But then now the converse now, it's more of I'm told that it's perpendicular. So now I have to say it's what? It bisects. I'm just going the other way around.
Okay.
That's the converse. Okay, now let's do 5.3. They say AB is a diameter of a circle O, right? OD is drawn parallel to the chord BC and intersects AC at E. Okay, let's see what they mean in a diagram. There. Okay, so I know I do have parallel lines. Once I have parallel lines, I have what?
F-U-N, fun. Dun, 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 dun. My bad.
I have fun.
Yeah.
Okay. So now I'm told radius is 10 centimeters, right? And radius is this entire line OD, right? So I know that the entire OD is 10. And I'm told that AC is 16. The entire AC from here to here, it's what? 16. And then now they say that prove that AE is equal to EC. Prove that AE is equal to what? EC. Right? Okay. So how do you prove this? Remember, did you see that this is a triangle?
Yeah, we have AC. We have... Wait, they said the radius is 10 centimeters. So AE... No, what? No, they said... they said the whole of AC...
Wait, I haven't started using that yet. Let's remove this. Right? Do you see that this is a triangle? This entire thing. It's a triangle.
Yeah.
Right? And do you see I have a line in the middle? And this line is parallel to this. What does midpoint theorem say?
The line... The midpoint... The line from the center is perpendicular to the chord.
A midpoint theorem for the triangles. It says that this line that bisects is parallel to the, remember that this line, once I can prove that it's parallel, I will know that this line here is half of that. Midpoint theorem, with midpoint theorem, right, when you have this triangle, this line in the middle, it bisects, meaning that if I had 10 here, if AB was 10, that means that if I make this E, my AE will be 5 and my EB will be 5. It bisects. So once this line is parallel to that line, it bisects both. Meaning if this was 40.
Wait, do you have notes? Do you have notes based on the on these like because I don't have the notes here with me. I don't know.
There, midpoint.
Yeah.
So midpoint theorem is saying that if this line, the half is equal to that half, and this half is equal to that half, then that means that this one is half of that. You see, DE is half of BC.
No, DE is equal to a half of, okay.
And these are what? A parallel, right? So in this case, what we are trying to prove, right, is that we are given that the lines are parallel, right? We want to prove whether this and this are equal, right? Our question, Tina, we are given do you see that these two lines, this one from the center coming to here, it's what? It's a radius, right?
Yeah.
So this is a radius, which is what? We are told that a radius is 10. Let me write it as 10. And from here to the circumference again, it's a what?
Radius.
It's also a radius, meaning it will be what?
10.
A 10 now. And there goes my mouse again.
Then OD also, right, will also be a radius, ne?
Yeah, OD is a radius.
Okay.
I cannot find my mouse. Finally. Yeah. This mouse disappears. It's a 10. So you see that I now have a triangle that looks like that. Right? Which I have proved this to be equal to that. Right? And I am told that these two lines are parallel. Don't I have a midpoint theorem already? Because it's like this one. When you have these two sides equal and you have the lines parallel, then you can conclude that, okay, that means that this is equal to that and this is half of that. So now I have those conditions with this one. I now have those, so I have told them that, okay, OA is equal to OB because they are what? They are radii, right? When I say my OA is equal to my OB because they are what?
Radii.
Right. And I am told that OE is parallel to BC. It's what? Given. Right? Therefore, midpoint theorem would tell me that what? My, AE will be equal to EC. I've proved it.
Wait, OE. Wait, what are they looking for? Prove that OAE is equal to EC.
Yeah. So I've told them that, okay, so I have OA is equal to BE, which is this and this. And I've told them that this is parallel. So therefore, midpoint theorem states that if it's like this, then that means that AE is equal to EC.
So since those two sides, whatever lengths are equal, the other two lengths has to be equal as well.
It has to be equal.
Okay.
And automatically we're also going to use that in the second one, because check, they now say that proof that E1 is equal to 90 degrees, right? Which is E1, this one is E1, right? You now need to prove that that's 90 degrees. Now, because you have proved in your previous one that AE is equal to EC, right? You now go to this one, you now say that, okay, my AE is equal to EC, which what I proved, right? So if you're using the answer from the previous and you the one did you say your reason is proved. So you proved it, and therefore the radius radius chord theorem says what? Because do you see that this is a radius?
Oh yeah.
So the minute that I have said these are equal, radius chord theorem states when a line from the center, if it bisects the chord, then it's perpendicular to the chord. That's now just what you need to mention here for you to now tell them that that means that that's 90 degrees.
Oh, okay. Wait, could I also have used the corresponding angles, because we know that C is equal to 90 degrees because...
Are you given?
Wait, can I not...
No.
Is it not because... no, wait. Is it not because of... What is it? Is it angle of a semicircle? You can't.
Okay, yeah, you can. You can too. Okay. So it is angle of a semicircle, meaning it's 90 degrees as well. So you could use that one, which you say that, okay, that's 90 degrees angle of a semicircle, and then that and that it's corresponding angles. It's okay as well.
Yeah. Okay. Wait, so your point, you said it was what? Therefore, since AE are equal... Since
this one and this one are equal, right? Radius chord theorem states that a line from the center, if it bisects a chord, then it is perpendicular to the chord. Therefore, E1 is 90 degrees.
90 degrees. Oh, so you used theorem 1. Oh, okay, yeah.
Okay. And then now calculate the length of ED. Move below ED. Okay, there is ED over here.
They always be asking these random snarks. Calculate the length. Calculate the length
of ED. So we are given the length of EC, right?
Yeah.
Is 16. So since we have proved that these are divided, that means that this is 8 and that's 8. So since I have a 90 degrees here, I can use Pythagoras to find what? EO, right? Once you have found EO, you can use, because remember that EOD is what? A radius.
Oh, then you're just gonna minus
the radius minus the answer.
Minus that.
It's OE squared plus 8 squared is equal to 10 squared, right?
Yeah.
Okay. What will OE be?
10 squared minus 8 squared, which is 36.
Root of that, which is 6.
Yeah.
So OE is 6, right?
And
so now OD is equal to OE plus ED. And then OD is the entire radius, which you are given as 10. OE you have calculated as 6. What you need is ED. Therefore, ED is squared 4.
Oh, that one was not as snacks as the one we did the last time.
Just that the one last time you were working with an R minus 1, you weren't told what the radius is, so you were now working with an R.
So if we didn't have given the radius, we're just gonna have to do that R.
Yeah, you're gonna have to work with the R situation, because you'd know that this entire thing is an R, which is the same as that entire thing is also an R.
We're gonna be R minus if we were given ED.
Yeah.
Okay.